Welcome all. I'll be running through this worksheet, which I labeled as 2-6 Algebra Proof Fill in the Blank for you. I'm starting with question 5 on the front side. I've actually started this for you a little bit here, and I'll just use my laser pointer to kind of show you what I've done already. And because I love my laser pointer and I love my Star Wars lightsaber, I'll use that as my laser pointer. All right, so this is what was given to you. I rewrote it so that it kind of I didn't have all this workspace up here. So this is the given and this is the proof. So immediately you should just copy down the given and write G-I-V-E-N in the reason. That should always be your first step. And you know this will be your last step, so I don't know if you can do this in 4, 5, 6 steps. I put 5 on here because that's kind of like what most people do with this problem, but by all means you could go higher or lower than 5 steps. So that y equals 7 is going to be here, but I don't really know if that should be there yet, so I'm going to wait. So going back to my marker, I'm going to alternate in colors so you can see each step done differently. The very first thing that I'm going to do is I'm going to multiply by 3 so that I can get rid of that 3 right there. So I don't have to rewrite this if I want to. I can just do times 3 and times 3. I know at the bottom in the word bank they rewrote this entire thing and put a times 3 next to it, and that's probably the best way to do it, but as a shortcut I'm okay with you just writing I was taking the last step and multiplying by 3. Since I am multiplying to both sides, that's called the multiplication property of equality. You must have the of equality. Changing to red for my next step. Well, once I do that, these 3's cancel and I get y plus 2. Equals 3 times 3 is 9. Every time I follow multiplication property of equality, I will follow that with actually my math, which is multiplication. After that, I need to get y alone, so I subtract 2 and I subtract 2, and I get y equals 7. You could have probably went through this whole side first, and that's what I'm trying to prove, so it looks like I'm good. What were my steps here? This step is subtracting to both sides. So subtraction property of equality, followed by subtraction. This should have been a really easy proof because we've done lots of these. I'm going to expect that this is all good for you on this section. That's the 2-6 section. When we move to the back side, the 2-6 transitioning to 2-7 section, I once again started with all the given information in step 1 here. So yes, you do have to write all of these parts in your given, but now I need to somehow get to this x equals 100. Well, where am I going to start? I actually believe I'm going to start right here. The problem with this is that's a congruent symbol. Whenever I'm working with this measure of angle y information, I need equal symbols. So the first thing I need to do is I need to make a leap from congruent to equal. So I'm actually going to write, instead of angle y is congruent to angle 6, I'm going to write the measure of angle y is equal to the measure of angle z. Sorry, I should have said z there. That is, let's see, definition of congruence anytime you flip those signs. Now, since I have it in the equals form, I can do math operations to get there. I can't really do math operations with congruence because congruence is about pictures. So this step is necessary here. The other day I did that step, but it was necessary at the end because the end had a congruent and not an equal. So I need to kind of oscillate back and forth between those. Now what do I do? Well, I didn't use this yet, so how do I use this? Oh, the measure of angle y is the same as x plus 10. So here I'm going to replace that. and z is 2x minus 90, so I replace that. What is a property, theorem, or definition that is replacing? Oh yeah, that's right, it's substitution. All right, well now it just becomes an algebra proof because I've kind of taken all this stuff, which is about angles, converted it to an algebra problem. So now it's just a regular proof. So, well, how do I just solve this? Well, subtract x from both sides. Or you can bring the 2x over, it's completely up to you. Subtraction, property of equality. And then I subtract, so I get a 10 here. Probably change colors, be consistent. Equals 2x minus 1x is just an x, minus 90. So then that would be subtraction. And changing colors here, I'm then going to add 90. Add 90. And I'm going to get x equals 100. So this was the, I should probably put the add here so I really illustrate that property. Addition, property of equality, followed by add. And I'm done. Oh no, I'm not. This was x equals 100, not 100 equals x. So I have to switch them. And that would be the symmetric property. If you planned ahead, let me use my laser pointer here. If you planned ahead right here and knew the x had to be on the left side, you could have subtracted 2x to start with, so your x was over here, then you wouldn't have had to do the symmetric property at the end. However, if you subtract 2x, you would get a negative 1x, and then you'd have to have division in here, and you'd have a division property of equality there. So that's it. I hope talking through this kind of helps you on proofs as you embark on your mission to attempt to do these algebra proofs all together here on a worksheet that you're going to get, and then start linking that and trying to do a little bit better on your geometry proofs. Thanks for listening.